This is how you make a key on a Volvo XC90.
Yeah!
This is partially EEPROM, partially OBD job. We're gonna have Thomas show you next in the video how to find the module, how to remove it, and then I'm gonna work on it in the van and get some EEPROM information, and then Thomas will likely finish off the programming. Might be me, we'll see. But if you guys wanna see the job before you start, always research jobs before you go to them if you're not familiar with them. That's super important. So we're gonna go into EMO. We're gonna scroll down or click on Europe to speed it up, click on Volvo. This part you can skip past. It says establishing a connection to the VCI, but you don't actually need to establish a connection to the VCI that connects to the car to check out the install guides or programming guides. So manual selection, because we're not connected to the car, it's not gonna be able to pick it up. We click on XC90. This is a 2018, so 16 to 21, and it's a smart key. Click OK. Okay, so click on control unit, keyless system. We need to, okay, so on the right hand side of the tablet here, there's a little book, a little blue icon with a white book on it. If you click that, it tells you it tells you what all these things do basically. So add a smart key, uses it to add a smart key. All keys lost, uses it to learn when all the keys are lost. Read CEM data. This function is used to obtain CEM data by reading CEM with a programmer. So the CEM is the module that we have to remove from the car and read the information from. CEM is located in the bottom left by the steering wheel. After removing component from the vehicle, perform the steps below. So we have to prepare the solder points on here, figure out which CEM we have exactly, and I'll show you that as soon as Thomas gets it out. So we'll move the video to Thomas now.
All right, we're gonna have to get underneath the steering wheel here, so let's see which tools we need. Looks like there's a couple of Torx. I'm guessing T25s. That is correct. All right, there's two T25s that hold this bottom piece on. You remove those. There's one plug here for the footwell light. The T25s are here and here. We'll put this off to the side, and then we'll work on the under dash piece here. Actually, it looks like this dash piece is part of the whole thing, so I'm gonna try getting the CEM out without removing it. Take this side panel off. Should be able to get through here though. So we're taking these two screws out of the top of the pocket here. They're both T25s as well. That'll give us a little bit more access to the CEM, which is kind of standing upright against the side here. All right, on this pocket, there's two T25s that go up here, and on the back it's just clips holding this in, and now we can see the CEM through this pocket. So this right here, all the wiring that goes to it is the CEM. That's what Volvo and Land Rover call their body control module. So let's get that out. All right guys, we got the CEM here. As you can tell, there's a bunch of plugs around here. There is this bracket, which is bolted in from the side here. So it's the bolt is kind of hidden behind the harness. Once you unbolt that, you get this out from this tab. There's two tabs in here. You have to release those. The CEM pushes back towards the outside of the vehicle. You can kind of twist it out, and then you have it out. So let's go to the bench. Fraser will do the EEPROM part of this, and then we're going to be back in the car after.
Okay, so Thomas got the CEM out of this thing, and we just need to pop this thing open. So there's a whole bunch of tabs all around the outside of this thing, and we just need to slowly work our way around those and pop them out. So I recommend like a pick and a pry tool. Kind of work it out. And then just get this in here. And just keep working your way down in a clockwise or counterclockwise direction. Once you start to see that the lip is popping up on the side there, you're doing good. Just keep working. There we go. And it helps having like multiple of these too. There we go. Okay, so here's the guts of our CEM. And now we need to figure out which one we have. So we gotta pop this out. Right here there's a little tab that's sort of holding the circuit board in. So same two tools, very gently prying on here, very gently, and then pushing in this tab without screwing up the board. There we go. And again, just be very gentle with the circuit board. You'll see those connectors start to fall out. That's a good sign. Now we have access to our board. Okay, so back on the tool, read security CM data, click OK. We're connected to our XP400 Pro, and it lists 3 different options here. So currently we don't know which option we have. So what we're going to do is we're going to pop this under the microscope and see if we can see anything on here. Okay, this might be really hard for you guys to see. Let's see if we can brighten this up a little bit. Okay, so on the board here, if we look at these main chips right here, these are going to be our processors. So we'll take a look at those. And we have an ON32E on both of those. So again, right here, ON32E SC66732-0MMJ1. So we're going to look at our guide. We're going to have a whole bunch of different options here. So first one is an ON78S, which this is not. This is a 32E. So keep scrolling. That's a 1N81M. That's not what we need either. Here we go, ON32E, ON32E. So on the Autel, you can see the mask ID, the chip mask ID, and on the physical board, you can see that this one matches up too. So we need to work with module type 3, which is a 667320. And I'm just going to take a picture of that so I don't forget. Always scroll through the rest of the options, because we have some more options here. So all these don't apply to us. Okay, so that translates to 667320. So we hide our guide here. And on the very right, we see that option SC667320. So click on that. That's how we know which one we need to choose. And now we need just to see our hookup guide. So go back there. Full screen this so you can see a little bit better. It was module type 3. ONE32E. Okay, so on the board, it's right beside our brown connector right here. So in between, as you can see on the screen recording on the tool, it's sort of in between these two, whatever these are, these big cylinder things, and in between the processor here. So all our connection points are going to be right in here, and they're actually fairly pretty big to work with, so that's going to be easy to solder some things on there. So first thing to notice is there's a coating on this board. We're not going to be able to solder onto the metal here because it's coated in like a rubbery coating. So first thing you do, MG Chemicals conformal coating stripper. Dip your horse brush in there and just let the chemical do the work. You don't have to press super hard, you don't have to get really aggressive with it. Just take your time, go back and forth on it. Add a little bit more until you can get the bare metal exposed. And then take your brush strokes and just go one way to get rid of all the crap that's on the top. Spray it down with a little bit of alcohol spray to clean it up. And hopefully we're ready to solder onto these things now. Okay, so we'll go to here now to make it a little bit easier to see. Maybe. Okay, we're gonna have to work on it like this. So just for reference, I'm gonna turn the tool sideways so I can directly work on them, and it's a little bit easier, it makes a little bit more sense. Okay, so first step before making the connections is we tin all the ones that we need. So we're gonna start with the red line on the screen recording on the Autel here. So you put a little bit of solder on the end of your soldering iron. This soldering iron is terrible. I need to get a new one. We go on here. It's the second one from the left on the top row. Oh, I forgot something. Flux, always flux. This makes the solder easier to stick to everything and is way less messing around. Flux on there, second one from the right, tin it. Come on, baby. Okay, see that little ball moving around? That means it is not sticking to anything, and that's not what we want. This is called a cold solder. So if that were sitting right there, it kind of looks like it's sticking on there, but I can just push it out of the way with my fingernail. That's a cold solder. That's not what you want to do. This soldering gun is just not great. I had some technical difficulties with the soldering iron here, so we're going to bring out Big Bertha and see if we can make this work. There we go, that looked better. Okay, so that solder actually flowed into the connector that we wanted it to, and it didn't bubble and just sit on top. So now we'll go to the one beside it. There we go. And basically all we're doing is just filling in those holes. There we go. And then we need the next three, so skip one. Okay, this is where it's hard to work with a big iron with a big tip on it, but we'll do our best. There we go. I think I got that one too. If you're ever having trouble making it stick, just put some more flux on there. Help things move around. There we go, that looks much better. There, you can see just from that quick touch up how much better those look. And there we go. Okay, so all the ones that are on our diagram on the Autel are now filled in with solder. And now we're just going to match the colors of these pins. So we take our red pin here. These already have a little bit of solder on the end of the wire. And we just tack them to here. There we go. So there's red done. Yellow. That one looks good. Blue. And while we're doing this, you just want to make sure that nothing is jumping, or bridging is the correct term for it. So we're not joining two things together that are not supposed to be joined together. There we go, blue's done. Brown is next. Just keep working your way from one direction to the other to make it easy to solder. I always go left to right because I'm right-handed, so it makes it easy to solder everything on the left and work your way right. There we go, good connection there. Green. That's what we're looking for. You're looking for that welding look. So instead of it's sort of looking like it's just attached to it, it should literally look like it's melted into it. And that's a nice solid connection on there. Okay, 2 more left. We got purple. Looks blue on the screen, but it's actually purple. And black. Last one, I'll try and make a nice clear view for you. And the flux is really helping with this process. There we go, give it a wiggle. Everything's on there nice and solid. Okay, so always double check these connections because we are sending power to the board. So we got red, yellow, blue underneath, and we got brown, green, purple, and black underneath that. So everything looks good on here. We need to make these connections at our tool now. So on the screen recording here, you'll be able to see the different colors going into the different pins, and then those correlate with these on the tool here. So first, let's start with blue. So orient it the same way as the tool, just to make sense of it, because these are actually not labeled. So the way that I know how to organize this is our VPP2 connection, red connection is right there, which correlates to this one right here. So that's how we know where to pin these IO numbers ones after that. So our blue is our first connection, goes at the very top left. Hopefully that makes sense for everybody. I know it's kind of confusing. Green is right beside it, purple is right underneath, and brown is right beside that. Now we can move on to the next row here. So VPP goes to the second one, which is also labeled VPP2. Reset is 2 past that, which is also labeled on here. And then our ground is the last one. This is where it gets kind of tricky. So I'm actually just going to hold it so I don't put any stress on the wires here. Okay, we're connected from our board to our tool to our tablet. Let's get out of here. Click on the 667320, which we already determined before is the one we need. And now it's data reading in progress, failed to read. Okay, so I probably need a 12 volt connection on here. So what we're gonna do is grab this. Thomas is gonna plug that in for me. Okay, so now we got 12 volts hooked up to our XP400 Pro. Let's try and read that again. Here we go. Okay, let's double check our work here. Sometimes we run into issues, we just need to double check our work. So what I'm looking for right now is to make sure these are all solid connections and they're not bridged, which means that they're connected to each other or anything like that. So it looks like everything is really good. Alright, so I'm just going to reseat these wires one more time. I definitely got them connected right. Weird. Okay, so what I'm going to do is just touch these all up with the soldering gun one more time to make sure that there's a good connection, and then we'll try it one more time. Okay, so I must have had a solder that wasn't quite good, even though it looked good under the microscope. I touched all the solder points up, and now it's reading. So it says data reading in progress will automatically be performed twice, and then the data will be compared from both files. So the reason they do that is to verify that you don't have a bad read and you corrupt the module. So this is really good news. I was worried there for a second. Like I said, always check your work and hopefully we're good. So the read data is consistent. Press OK to save the data. So we're going to click on that and we'll save this as XC90 at the beginning. XC90 and save it. So we know how to tell it the difference between all the other ones on there. So save is done. Okay. So now we're going to back out of here. And now we can proceed with the all smart keys loss function. But what I'm going to do first is disconnect everything from here, desolder these, and then just check things. You'll see how much faster it is to get rid of soldering versus installing these little pins. Always clean your tip. There we go. we go. There we go. Okay, so if you want to be really, really deadly, you could clean all of these out with some solder braid. It's not required. If we ever had to come back, this would make the job a lot easier. So we're just going to leave it. Spray it with a little bit of alcohol. And just clean the board up a little bit to make sure that we don't have any bridges there. So you can see on the microscope it's nice and clean, and none of these pins are jumped to the other pins. That's the most important thing. Okay, so now we're reinstalling the chipboard onto our piece. Something to keep in mind when you're doing this is these pins right here. So these are just long, flimsy metal sticks basically, and they fit into these tiny little grooves to keep them guided in the correct place. So when you're working on the chipboard, don't be ruthless with this thing, like throwing it around, because if you bend these, you're gonna have a really, really big problem later. So nice and gentle, drop it on top. We'll see that guide pin line up on the top of the circuit board here, and you should see all those pins start poking through. That click means that our plastic snapped onto the chipboard there, and we just need to put the back on. So this one's super easy. It is directional, so you'll see this little indent on here, little indent right there. Never force anything. If it's not going, take a step back and look at what's going on. It should go in nice and easy, just like that. So now it's ready to be installed back in the car and then finish our OBD programming.
Getting ready on my knees here. All right, guys, as you saw, Fraser's done with the CEM. We're gonna put this thing back in. The snow has definitely picked up here, so let's try to get this as fast as possible so we don't get so much snow in here and get back into the warm. Install is really just reverse of removal. Like I said, this belongs in here, but I'll snap that in once this is in place. So we're gonna be putting this in, twisting it in, and there's two guide pins in here. We're gonna get that to snap in, get this bolted in, and then we're gonna put all of our wire guides on here and put all the connectors back in. This should be a lot faster than taking it out. So let's do this. All right, the CEM is back in, all plugged in. Let's put this little pocket back in, the side panel and under a dash panel, and then we can start programming. One more thing that I forgot to mention earlier. When you do this, make sure to disconnect the battery. This battery's stone dead in this. No matter what you do, that's you don't have anything, so we didn't have to disconnect it. But always make sure you have the battery disconnected when you take the CM out, just to save yourself some headaches from some fault codes. So we have our two new Volvo keys here. The key learning slot on these is in the front cup holder. You can see the little key emblem in there. Ryan's going to show you that. So we're going to be placing our key right in there, laying it in there. It's going to be our learning slot. All right, and we're going to be using the all keys lost function since we do not have a key. Turn the start stop button to the right and release it. Okay, so this is your start stop button. All vehicle keys will be erased. Do you want to continue? Okay. Execution of this function requires loading of CEM security data, which can be obtained with the read CEM security data function. Do you want to continue performing the function? So this is asking now for the data that Fraser read in the van earlier off of the CEM. So we want to hit yes. Please load the CEM data of this vehicle. Press OK to select the corresponding CEM data. Okay, so now this is bringing us to our saved folder here, and we have the XC90 Volvo CEM that is from today's date. So we're going to be selecting that, hit OK. So now it's reading all of that, reading the VIN. Key erasing successful. Hit OK. Establishing vehicle communication. Turn the stop button to the right once, then release it. Okay. I assume that is to wake it up. Place a key to be learned to the key sensing area, which we already did. The induction zone is generally at the position of the key mark on the cup holder, and take other keys out of the vehicle. So I'm gonna take this out. Actually, I'm just gonna grab the Faraday bag for this to show you a different option here. So these are what's called Faraday bags. or Faraday bags. I'm not sure how exactly you pronounce it, but they have a material on the inside that blocks the radio frequencies of the keys. So when the key is in here, the car can't see it. So just gonna put that there. This is an empty one. So once we swap the keys, I'm gonna put this one in here and take the other one out. Okay, key learning successful. Would you like to learn the next key? Yes. Turn the start stop button once and release it. Okay. Place a key to be learned in the sensing area and take all the keys out. So put the learned key in here. Take this one, put it in the sensing area, hit OK. Key learning successful. Would you like to learn the next key? No, we're only doing 2 keys for this one. And that should be it. So, locked, unlocked, and the ignition turned on. So I assume we're going to need a booster. All right, our booster's going. Let's jump in here. There we go. It's running. All kinds of warning signs. Let's turn this off. Grab the other key. There we go. We're all good to go. Fraser already cut the emergency key. There we go. Take the back off here. Emergency key slides in there. Fraser already cut it. It's an HU101, so it's same as a Ford key or a Land Rover key. And then the shells just snap and slide together like that. Now they don't come apart. We have 2 good working keys for this, and this is all done.
Okay, so there's a special leashy for these door locks. The door cylinder is hidden behind the door handle, so you got to kind of find a way to prop it open. I just use this level because it maximizes it and fits it in perfectly. So if you check out this, that's where we need to insert, or where the emergency key goes, to be able to unlock and lock the car. So as you can see, it'd be kind of difficult picking that, because normally our tool just sits like this outside the car and it's really easy. But I'll show you how this one goes in. So this is our HU101 leashy. This is an 8-cut door lock. These are 10-cut leashies. They still work on the 8 cuts. You just have to use cuts 1 through 8 and you ignore 9 and 10. So a regular HU101 leashy looks like this, but the problem is the leashy is going to hit the handle right here, so we can't get the leashy all the way in. So what we need to use is this guy that just sneaks past it because of this indent in the leashy right here. Now, I had to put it in like this because I need to access my torsion bar right here and pick it sort of backwards. So just do your best to get comfy. You have to do it upside down. It is a little tricky, but just get comfortable first and then be patient and work on it. Sometimes you have to work backwards. Okay, so you guys are probably wondering like, oh man, that's a lot of work for making a key for a car, but there's a lot of profit in this job as well. So our cost on the keys is probably less than $100 each, and with shipping and everything, and we charge almost $1,300 for the job. So it's over $1,000 profit. It took us about an hour, and that's how you can see that these jobs are worth it. The alternative is you could purchase an OEM software subscription and use a pass-through like Cardac. You guys have seen us use SPS, YTech, some other OEM software, but we could use Vita, which is Volvo's factory software. We literally just plug in our tool, we can buy the key code, we can do all that, but it's cutting into our profit. So it probably costs us, I don't know, an extra $100 or $200 just to use all those tools. And I like showing you guys the different methods and different things that you can do with the cheaper tools. So just a couple different ways to show it. We'll do another video one day where we use OEM software just to show you both options and the difference and pros and cons of each. Yeah!